Good morning, afternoon, evening, or wherever you are. My name is Angie, a member of Salo's team, a deepfake detection integrated audio calling application, and this is our group marketing and technical presentation video. To start off, let's talk about the issue at hand. In our modern world, as technology advances at an astonishing speed, everything that we thought was impossible will become possible one day. Sadly, this means that adversaries can also leverage this and come up with more innovative attacks, which can be, in our case, deepfake audio scam call. An attacker only needs 1 or 2 sentences of you speaking to capture your voice and generate a sentence that is manipulated to trick your family and relatives. The victims of these attacks, or in other words, our potential clients, range from an average citizen whose voice can be mimicked to large corporations that are involved in transactions over the phone or lack voice authentication security. Let's talk about our analysis of the market. Currently, there's no mobile application that detects deepfake audio calls on the market. The closest business model are websites that can detect whether an audio file contains deepfake or not once a user uploads onto them. In that sense, there's not much competition for the application at this moment. Our 2 primary targeted groups of users are the average individual and businesses that are involved with transactions via phone. For the average individuals, as deepfake audio scam is getting more and more popular, especially with the advancement in artificial intelligence, people will start to look for a solution that lets them securely communicate with others. For the businesses that are involved with transactions via phone, such as banks or agencies, their client needs to know that the business will only proceed with the transaction with their voice only, and the business needs to identify which calls are from the legitimate clients or malicious individuals. There are 2 primary advantages of the application. Firstly, it is a mobile application, which means that it operates on a mobile phone, which is primarily meant for calling. This means that anyone who needs to ensure that the call which they make or receive is secure can easily access the solution that is made for them on their desired platform. Secondly, not only does the application provide the feature audio call deepfake detection, it also has additional features like deepfake audio file detection, cybersecurity lessons, and contact management, which can be leveraged in the future to build an ecosystem or media platform that puts the safety of the user as its primary goal. Now, let's move on to how we can leverage the marketing mix to promote the application in a way that is aligned with customer needs and business goals, which include product, price, place, promotion, people, process, and physical evidence. For the aspect of product, we will be focusing on promoting its core and unique function, which is the deepfake audio call detection, and also the user-friendly interface that creates a comfortable experience for the user. Regarding the aspect of price, since communication is a basic need, we are planning for a freemium model with certain feature restriction for the daily user, which they can unlock with payment and custom pricing for enterprise. The place that we want to promote our application is on both the Google Play Store and Apple Store, so our product can reach the most possible amounts of users. As for promotion, we can leverage digital marketing like Google and YouTube advertisement, or even more simply, public relation, as the threat of audio deepfake scam is growing by the day. For the aspect of people, the team will ensure that the users have access to real-time support, and the product is developed and maintained by top experts in the field. The process aspect will emphasize on the continuous maintenance and updating of the application for our customers to stay ahead of emerging deepfake threats, as well as additional features to improve the user experience. Regarding the aspect of physical evidence, we would like to emphasize on our user interface, which reflects professionalism and security, ensuring users feel confident in the application's capability. Let's move on to the technical discussion. We will be discussing the following key points, which are architecture, technology, functionalities, and communication protocol. Firstly, let's talk about the architecture of the system, which is made up of 5 major components, which are model, database, server, mobile interface, and web interface. The model plays a crucial role in the architecture of the system. Its primary role is to analyze audio files for deepfake audio content and return the result. The database is where all the data of the application is stored. It contains the information of the user, contact book, call history, report log, and educational content. It works alongside the server to store and retrieve the previously mentioned information to be displayed to the user. The server is the heart of the system. Firstly, it plays a crucial role in implementing the functionality of the real-time call deepfake analysis system. Secondly, the server acts as a bridge between the front end, where the user interacts with, and the database, where their data is stored. Every HTTP request which fetch, update, delete information in the database from most functionalities must go through the server first, and only after being processed can the request go to the database, and then the result will be communicated back also through the server. For the backend, the team uses the combination of Node.js and Express to implement the server, as we are able to synchronize the use of JavaScript on both front-end and back-end. This full-stack JavaScript approach simplifies development by ensuring consistency in logic and data handling across the entire application. By leveraging Node.js, we benefit from its non-blocking, event-driven architecture, making it highly efficient for real-time applications like ours, where low latency is critical for smooth audio call performance. Express, being a lightweight framework, allows us to build robust. Now let's discuss the technology behind the scene in which our application is built from. For the front end, the developer uses React Native with Native Win to implement and style the user interface for a reactive and fluid user experience. React Native allows us to create cross-platform mobile applications, ensuring a consistent UI across both iOS and Android devices. With Native Win, we can leverage the utility-first styling approach of Tailwind CSS, making it easier to apply styles dynamically based on app state or user interaction. This not only speeds up development but also enhances the app's performance by reducing the overhead typically associated with traditional CSS. Native Win allows us to efficiently create responsive layouts, ensuring the UI adapts seamlessly to different screen sizes and orientations. By integrating Native Win, we focus on creating reusable components and ensuring accessibility, contributing to an intuitive user flow. Additionally, the flexible styling system helps us implement real-time feedback mechanisms during the call process, such as visual cues when a deepfake is detected or connection quality fluctuates. For the backend, the team uses the combination of Node.js and Express to implement the server, as we are able to synchronize the use of JavaScript on both front-end and back-end. This full-stack JavaScript approach simplifies development by ensuring consistency in logic and data handling across the entire application. By leveraging Node.js, we benefit from its non-blocking, event-driven architecture, making it highly efficient for real-time applications like ours, where low latency is critical for smooth audio call performance. Express, being a lightweight framework, allows us to build robust RESTful APIs, handling routing, middleware, and integration with various services. Using Node.js also enables us to handle concurrent audio streams and perform real-time deepfake detection on the server side. As the server receives audio data, it processes it through our AI deepfake detection models, which are built using tools like TensorFlow or PyTorch. Once analyzed, we can provide immediate feedback to users about the authenticity of the voice, all while maintaining the call quality. This architecture ensures that we can seamlessly manage the audio call and deepfake detection workflows concurrently without compromising performance or security. For the storage of data and information, a relational database has been chosen by the development team to implement for the application. The database management system in use is MySQL. MySQL is a widely trusted and robust database management system that provides structured data storage, ensuring the integrity and consistency of the information we manage. Given that our application involves handling various types of data, such as user profiles and call logs, a relational database is ideal for organizing and retrieving this information efficiently. With MySQL, we can create well-defined schemas to maintain relationships between different data entities. For example, we can easily associate a user's account with their call history and store metadata related to deepfake analysis for each call. This allows us to perform complex queries such as retrieving a specific user's call records or reviewing the deepfake analysis results in real time, while ensuring data consistency and minimizing redundancy. Moreover, MySQL offers strong transactional support, which is critical for maintaining the accuracy and reliability of data in a real-time application like ours. Whether it's ensuring that all aspects of a call session are properly recorded or managing concurrent access by multiple users, MySQL ensures that data integrity is preserved even under high load. We also leverage indexing and optimization techniques within MySQL to ensure that data queries related to call detection and reporting are executed rapidly, contributing to the overall performance of the app. Raw Graph Attention Network with Spectral Temporal Attention is an innovative end-to-end model designed for anti-spoofing and speech deepfake detection that is built with Python. The sophisticated architecture operates directly on raw audio waveforms, leveraging the power of graph neural networks combined with spectral temporal attention mechanisms. The model's architecture begins with a raw audio waveform input, which is processed through a sync convolution layer for initial feature extraction. This is followed by a 2D residual network for further feature learning. The core of the model consists of 3 attention blocks: a spectral attention block, a temporal attention block, and a spectral temporal attention block. Each of these blocks incorporates graph attention networks to model relationships between different acoustic cues. Graph pooling layers are employed within each block for selective note retention, enhancing the model's ability to focus on the most informative features. The model culminates in a model-level fusion of spectral and temporal information, leading to a binary classification output that distinguishes between bona fide and spoofed speech. The model's strengths lie in its state-of-the-art performance, lightweight architecture, and ability to effectively capture both spectral and temporal cues. Handcrafted features are specifically designed to capture the unique properties of the speech signal that are useful for a particular task. However, they can be limited by their design because they rely on domain knowledge and assumptions about what constitutes a relevant feature for spoofing detection. This is where the raw GATSD model stands out. Instead of relying on these predefined features, it learns the most relevant features directly from the raw waveform in an end-to-end manner. This approach allows the model to automatically capture subtle cues that may be missed by traditional handcrafted features, improving its robustness against a wide range of spoofing attacks. One of the most important aspects of our system is its functionalities and the development process behind them. We are going to look at the audio call signaling system, real-time call deepfake analysis system, personal information and educational content, as well as audio deepfake file detection system. Firstly, let's examine the audio call signaling system, which makes the user feel like they are using a calling application. Upon initiating the call, the mobile interface will embed the web app within a web view and send the necessary data like who is the receiver to it. The web app will communicate with the server to check if the caller is soft-banned, determined by the number of times a user is reported by others on suspicion of deepfake usage, and if the receiver blocks the caller. This information is retrieved from the database and then computed by the server. If the conditions of the call are met, the server will log the call history in the database with the default call status set to missed, and then check if the receiver is online. If the receiver is not online, the server will send a message to the caller. If the receiver is in a state to accept the call, the server will ping them. If the receiver accepts the call, the mobile interface will initiate the conversation, else if the receiver declines, a request will be made to the server to modify the call history status to declined and send a decline message to the caller. Now let's go through the real-time call deepfake analysis system, the core of our application. As long as the connection is active, the web app will periodically record the audio data and send it to the server through a WebSocket connection. WebSocket is a communication protocol that provides full duplex communication channels over a single TCP connection. It allows ongoing and two-way communication between the front end and back end. This allows the front end to avoid waiting for the response from the analysis, which can halt the calling process. WebSocket allows the server to send a message to the front end without needing the front end to request anything. This allows the calling process to happen in parallel to the deepfake analysis process, but the speed of the analysis will not affect the calling process. When the server receives the audio data, it will convert the data to audio file format suitable for the model and send it back to the model for analysis. If the deepfake content is found within the audio, a message will be sent to warn the victim through the WebSocket connection. Concurrently, the server will also flag the call history with deepfake detection in the database in order for the user to review call history and statistics later on. The application allows the user to customize their experience to a certain extent and also provides cybersecurity-related lessons for the users. For the retrieval or modification of personal information and educational content, the user sends a fetch, update, or delete request to the server. The server will receive the request, then authenticate and process it by applying business rules before sending the query to the database. After the database returns the information, the result is processed by the server and sent to the mobile interface in a styled and readable format. Last but not least, we also provide a way for the user to detect deepfake content in their chosen audio file and test our model. For the detection of deepfake within an audio file, the user uploads and sends an audio file to be detected to the server. The server will receive the file, check for integrity and validity before sending it to the model for analysis. After the model analyzes the file and gives back the result to the server, the information will be processed and returned in a styled and readable format to the mobile interface. Finally, we are going to look at the communication protocol that enables the transport of information between components of our application, which are Hypertext Transfer Protocol and WebSocket. Hypertext Transfer Protocol, or HTTP, is a protocol used for transmitting hypermedia documents which operates over TCP/IP. It is a request-response protocol where the client sends a request to the server and the server responds with the data, in JSON format in the context of the project or error message if applicable. For the mobile and web interface, we primarily use the method GET and POST to enable HTTP protocol. WebSocket is a communication protocol that provides full duplex communication channels over a single TCP connection. It allows ongoing and two-way communication between the front end and back end. The team primarily uses WebSocket to enable the functionality of real-time call deepfake analysis system. To be more specific, WebSocket is used to periodically send the audio buffer data of the incoming audio from the other user in the conversation to the server so that it can be converted and analyzed by the model. Further to this, WebSocket is used as a way for the server to directly ping the user on the web or mobile interface when there is an incoming call and when the other user audio in a conversation is detected with deepfake. Thank you very much for listening.